I'm here with Andy Gordon. He's going to tell us a little bit about where he comes from, what his interest in spreadsheets is, and then he's going to talk to us about his keynote speech that he's going to give at EuSpRIG 2024.
Thanks, Simon. Yeah, my name is Andy Gordon. I'm a computer scientist. I had a long career at Microsoft Research in Cambridge. I was 26 years there. Before that, I did a PhD in functional programming, in fact, using Haskell at Cambridge University. And I was a postdoc in Sweden for a year as well before coming back to Cambridge. And then shortly after that, I joined Microsoft Research. I think one reason I'm here at EuSpRIG is that the last sort of 6-7 years that I was at Microsoft, I worked closely with the Microsoft Excel team. We did something called Project Yellow, which was introducing sort of new programming ideas into Excel. And we introduced Lambda. We introduced entities in cells that can hold things like stock prices and companies or facts about cities or countries, or really anything that can be represented as a structured value. And then we did a bunch of other things around spreadsheets and built a really good relationship with the Microsoft Excel team. And the last thing that I was involved in before I left was Excel Copilot, which in fact I spoke about at EuSpRIG in 2023. So that's a bit about my background. So let me say a bit about what I'm going to talk about at EuSpRIG this year, and that is uncertainty. People deal with uncertainty every day: durations, demands, prices, rates. And when we think about big societal questions like climate change or the pandemic, even the experts in those subjects are uncertain about predictions concerning the state of the world. So uncertainty is just really something very important to represent. And people use spreadsheets to deal with the kinds of situations I've spoken about. But actually, spreadsheets are quite bad at representing uncertainty at the moment. And this talk is about ideas that can be applied to make spreadsheets much better for dealing with uncertainty.
Uncertainty is a particularly interesting issue to come up against, and I agree with you around how spreadsheets are not particularly good at dealing with uncertainty. So can you give us some idea of how you might overcome those issues?
Sure. So the sort of technology and concepts for dealing with probability distributions are have really improved. I mean, I first started looking at this area about 10 years ago, and I started to do research on something called probabilistic programming. And at the time, that was pitched as the next way to do artificial intelligence. It was even pitched as a way to democratize artificial intelligence and machine learning, so everyone can do it. And we thought, how could you apply these ideas in the context of spreadsheets? And thanks to what we did in Project Yellow in Excel, you could now store uncertain values inside cells. So think about these entities I spoke about earlier that can hold like a collection of what we call keys and values inside a cell. You can use those to represent things like stock prices, but you can also use them to hold some sort of representation of uncertainty, such as an interval. I mean, that's a classic way to represent uncertainty. Instead of just saying, well, I've got an uncertain number 7, you might say, I I want to think about an interval 7 plus or minus 2.
Mm.
And an interval like that can now be held as a single sort of value that sits inside a cell in say Excel. And then you can use lambdas to define operations that act on intervals and manipulate them. Like you can sort of encode arithmetic on intervals that would take two intervals and multiply them together, and you get a resulting interval. There's a sort of standard theory of interval arithmetic that can now be encoded in Excel using lambdas. And also, like for full probability distributions, that's sometimes represented by a set of samples. And now we can hold a whole array inside a cell. And hence you can represent, say, an array of 1,000 samples could be a whole array that sits inside a cell. And similarly, we can take, you can use lambdas to code up arithmetic over these distributions, and hence do calculations with uncertain values, and then preserve the uncertainty, and you end up with a final uncertain result inside a cell. And then you might say, well, fine, so I've got this uncertain value in a cell. How can I sort of interpret that and understand that? And there's different things you can do. You can have a sort of visualization of sort of facts about the distribution, like its min and its max, and its mean or its median. Or you can, and that's pretty easy to do today in a spreadsheet, again, using lambdas. Another thing you might want to do if you do some calculations and end up with maybe an array of uncertain values is that you might want to get some sort of chart that represents the uncertainty. And that is harder today out the box in Excel. But looking a bit further out, there's been very interesting research on how to have charts that encode uncertainties. It's a bit hard to describe in a podcast setting, but if you've maybe seen some of these visuals from like the Bank of England does it. They sort of predict what they think inflation is going to look like, over the next few years. And instead of just having a single line to show what the prediction is, they'll use a sort of contour plot where there's sort of a middle band that's kind of in a darker color, and then a broader band where it's less likely but still possible for an inflation to get to would be shown in a lighter color. So in the world of R, the programming language, there's been very cool work done by a professor called Matthew Kay, and he's built something called ggdist, which is a generalization of ggplot2, which is a very well-known plotting library for R. And what Matthew Kay's system does is to allow visualizations and distribution, allow visualizations of distributions and uncertainty as charts of the sort I'm talking about. So you don't need to know anything about graphics to get these nice charts. You just feed in uncertain values in R, and you get these charts out. And what I hope is that kind of technology will wind up in spreadsheets before very long. It's certainly something that could be added without too much difficulty. And that would make it much easier for people using spreadsheets to be able to visualize the results of their calculations that produce uncertain values.
Yeah, that's really interesting. It's something that I've run into a number of times in different settings. So in the kind of digital marketing sphere, where you've got quite a lot of uncertainty around, say, services that a company might offer. So they'll say to a client, if you do this, and this, then your organic search visibility, so where you come up in, say, Google's results, could be between here and here. And so that's quite a nuanced message to kind of get over, to say there is some there's some uncertainty exactly as to where you would end up. but these are the range of possibilities, basically. That problem is a significant one because often it's misunderstood, and the value of what's being offered then is also misunderstood, because they can't, kind of grasp that there's some potential for it to work out and some potential for it not to work out. So visualization is very, very challenging. And so something, as you've described, would be much easier then to get that across, I think.
Yeah, that's right, Simon. Yeah, the example you talk about, or that sort of situation, where sort of people find it hard to grasp what the uncertainty means, is, I mean, that's long been a sort of worry to people who sort of work in the, you consider how to communicate uncertainties. And there's actually been a big fear that if experts included uncertainty in their predictions, that it would undermine trust. Like when I first started looking at this area 10 years ago, that definitely was something that we spoke about, and we heard anecdotes of people in presentations feeling they had to give a specific number rather than showing a bit of nuance and showing that there was a range of possibilities. And I think particularly in communicating to the public about, with uncertainty, I think scientists have been concerned. But I was heartened. There was recent research by a team in Cambridge looking at the effects of communicating uncertainty on public trust in facts and numbers. And they did a big study, in fact, with the help of the BBC, looking at communications around like big societal questions like global warming and immigration. And what they found was that they could measure the trust that individuals had in the results of the communication. And they found that there was only a slight decrease in trust when you included uncertainty, but also a sort of increase in the sort of respect that the people had in the scientists and in the communication. And so overall, they felt it was and respect that the scientists were being transparent about the limits of what was known. And so this seems to be evidence that it really is worthwhile trying to communicate uncertainties, because it increases the degree in which people will sort of accept the findings of the studies.
Yeah. I've seen some with my other hat on. I do a bit of work with the EPSRC, and climate action was one of those areas where that was a chosen, I guess, domain to be working with uncertainty in. So I've seen a few bits of work around that, and that I found really interesting because there is a degree of uncertainty with the climate, even in our predictions around 1.5 degrees. I think we all thought that last year perhaps we breached that, and I guess the likely trajectory is probably higher than that, but then again, it's difficult to discuss it in a kind of publicly consumable way, with all this nuance and letting people know all of these different possibilities. And visualization was the vehicle for that. So yeah, fascinating stuff. Yeah.
I'm feeling, increasingly confident that it will be that it's going to be just much easier to communicate this nuance and have it understood. I mean, look at, say, weather forecasts. It used to be you would just get sort of fuzzy prediction of whether it's going to rain or not tomorrow. And now we're really used to seeing percentages of whether it's going to rain, and percentage, probabilities of whether it's going to rain in the next half an hour. You see these, from various weather sites. They're very good at having visuals that show uncertainty, and I think people are increasingly accepting them. So all that is good in terms of the possibilities there for the public as a whole to be able to understand when scientists try to communicate findings with uncertainty. And in fact, I think would expect it now, because they realize that we can't be completely sure about the future. But science is great because it can put bounds on the uncertainty of predictions. So I think scientists want to communicate this, and the public, I think, is ready to accept it. But I think technologically, we've had the problem that it's been quite hard to produce these kinds of plots. And that's a reason I'm so excited by the fact that spreadsheets now can hold uncertain values easily and compute with them. And also, there's been work by this professor I mentioned, Matthew Kay. His sort of theories of how you can, or his APIs for how you can, build graphics packages that generate plots that have uncertainty within them. Those are great models for charting that could wind up in spreadsheets. So it's going to be a lot easier for scientists to meet the public curiosity for predictions that transparently also include the uncertainty.
Yeah, absolutely. That should be very interesting to see. It's a problem we've come across many a time. Data science, really needs this. Because I think really the kind of bigger picture, something like Excel is such a critical, cog in many systems, and it will become even more important, I think, within data science, with the, obviously we can, you can code, you can script in Python now, but as I understand, it's not, it's a version you have to pay for. So, but one can imagine a scenario where that is just part of the, the regular functionality. And I think in that scenario, it's going to hoover up quite a lot of data science type projects, assuming you don't have to do too much data handling at the front end. So yeah, having that within Excel as well as, all the rest of its functionality will solve a lot of problems for a lot of people, I think. Because Excel is always somewhere in the process. You always end up in Excel trying to understand the data or just trying to get a look at what this looks like, or very quickly trying to understand perhaps what the averages are without having to kind of develop the code for it. I've done that many a time. Well, that's brilliant to know. I can't wait to see the impact of that technology.
I'll say also, I mean, I've really spoken about the sort of the way in which you can represent distributions inside Excel, and how we could have plots that would show uncertainty. I'm not saying anything about generative AI and its impact on modeling with uncertainty. And I'm very optimistic that using large language models in conjunction with tools or with spreadsheet tools will enable us to model uncertainty more easily. I mean, look at the data analyst package that's part of ChatGPT from OpenAI. It effectively lets you do spreadsheet type work within ChatGPT. You can upload data in a spreadsheet and then ask it. You ask it just in words, give me some insights about this spreadsheet, and it'll read the spreadsheet and generate some Python to do analysis on the spreadsheet. that's sort of OpenAI's universe where they generate the Python code and it runs within ChatGPT. I think Microsoft or other players, I mean, I'm not directly involved in this anymore, but I think spreadsheet providers can use similar techniques to generate Python. I think we actually are seeing that already from Excel and Microsoft, that there's a sort of co-pilot that it can generate Python code that would run within the spreadsheet. And I'm pretty optimistic that we can, we'll be able to prompt large language models to generate models that incorporate uncertainty as well, whether it be ultimately represented as sort of calculations using spreadsheet formulas, or whether it's done, say, as Python that's embedded within the spreadsheet. Or we might even get sort of rival data science or data analytics environments, say, that have R as a backend. So like I'm excited about this ggdist package in R. I mean, I suspect it would be quite doable to build a spreadsheet-like environment that had R as a backend and maybe used natural language as an input. Just as we can generate Python from natural language, we can also generate R to do analytics from natural language. And that would be a way to sort of allow an end user to generate plots using ggdist or more easily. So yeah, Simon, I'm really excited about all the possibilities, even if this isn't all there out of the box in Microsoft Excel today.
Yeah, absolutely. The kind of intersection of generative AI and other tools is really exciting. And as far as generating Python is concerned, it's very, very proficient at that. I have taught my students to do it, so we've gone from 0 to having a deep learning neural network in about 20 minutes. They have some of them had some prior knowledge of Python, but not of the machine learning side of it. And we just used GPT to generate the code and to troubleshoot the code as well. Because inevitably, it makes a series of assumptions about what you have installed or whatever it might be. But yeah, it's really, really powerful from that point of view. It does make me, I mean, of course, it's a tool that helps you do things. It's not, I guess it's not the replacement for the thinking or the actual, the person with the knowledge that you need, but it is an extremely efficient way, if you have the right input, to generate something that you need in terms of code or, whatever it might be. Yeah, brilliant.
Yeah, I mean, I think it's super important if you use GPTs to generate code. It's super important for the end user to understand what the code is doing. And it is actually pretty encouraging that you can often get the GPT kind of in a separate call to explain the code back to the user, or to explain outputs from the code, a particular run that the code has gone through. So the end user is much clearer about what computation has been done on their behalf. We have to be really careful with large language models that we don't sort of bamboozle the user and get them to accept results that they don't understand. So we need to help them to be skeptical about anything that gets produced.
Yes.
But there's a lot of work at the moment on helping the end user be more sort of critical about outputs from large language models.
Yeah, absolutely. I mean it is an enormously powerful tool, but yes, absolutely, you have to be paying attention to the outputs. You have to have the ability to verify what it's saying in order to know that what you're generating is valid. but also that you know, I guess from an optimization point of view, that you've given it all of the things that it needs to come up with the best solution. So that kind of critical thinking process is really important, rather than just sort of diving straight into it. You know, these generative AI feels very analogous to spreadsheets, really, where you know, the major thing it's bringing you is access and flexibility. And what do we see in Excel? We see a whole group of people who never plan anything, who never test anything, and they just dive straight in, generate, you know, create the spreadsheet. But no doubt it contains omissions and, you know, logical errors and other things, simply because they didn't take the time to try to think in broad terms about what should be in this model, what should be out of it, how the data is going to be processed, what the output should be like. So yeah, I think there's lessons to be learned, most definitely.